Okay, so yesterday we went over some transformations. Today we're finishing, we have two new ones. We have our vertical stretch and our vertical shrink. Okay. The two main things that are going to give these away, your vertical stretch your factor is going to be greater than 1. Like your multiplication factor, what you're multiplying by is going to be greater than 1. Okay. For your vertical shrink, your factor is going to be less than 1 but greater than 0. Okay, like 2/3, 3/4, or 1/2. Something like that. Okay. So, what they give us here on our first example of this, yeah, go ahead.
What if it is 1?
Then it's just the regular graph. Then it hasn't been changed at all.
So does that mean like the rest of it's like decimals?
What do you mean?
I'm confused. I don't understand. It's okay.
Let me show you. Okay? Give me 1 second. Let me show you. Fractions are decimals. Right? They're all one and the same. Okay? So let's say they give me the function r of x equals 3x squared. Okay, there's my factor because I know my parent function is y equals x squared, right? What family does this belong to? Quadratic, okay? And it forms a parabola as a graph, right? Okay, so what's going to happen here, let's graph this. This is the first thing they want us to do. So I'm going to make my xy chart. I'm going to pick -2, -1, 0, 1, and 2 just because they're the easiest to plug in. Sometimes you might have to pick extra numbers depending on where those end up. So I take -2, I square it to get +4 times 3 is 12. -1 squared is times 3 is 0 squared is 0 times 3 is 0. 1 squared times 3 and 2 squared times 3, 12. Okay. So I graph this now, and I go to from -2, and I'll put that 12 on there as best I can. Your graphs will go higher, but this one just doesn't fit. -2, 12, -1, 3, 0, 0, 1, 3, and 2, 12. Okay. And I know it's a parabola because it was a quadratic. So that's what my graph looks like, or as close as I can get it by hand. Okay. Then they want us to graph the parent function. Okay, well the parent function to this is just y equals x squared, right? Okay. So if y equaled x squared, I'd still have 0, 0. If I plugged in 1 and squared it, I'd get 1. If I plugged in 2 and squared it, I'd get 4. 3 would give me 9. Okay? Yeah? The red is our new function. I'm graphing the parent function in blue.
Oh, okay.
Okay? 1, 1, -2, 4, -3, 9. Okay, so my parent function's there in blue. My new function that they gave us is in red. What is this? Is it a vertical stretch or a vertical shrink? It is a stretch. Now, this confuses people because they say, oh, well, but it got smaller. Right? Well, it did. But we're using the word vertical, right? We are stretching it more vertically. We're making it more vertical than it used to be. Okay, so when you're using the word vertical, a stretch is going to make these lines steeper. So a shrink would have went out. It would have laid it out some more. It would have been less vertical than it used to be. Okay, that's one way to tell just by the fact that it's inside the parent function. Another way, that number's bigger than 1, right? So it has to be a vertical stretch. Okay. We'll do another one. Okay. This one, they give us that P of x equals 3/4 the absolute value of x. Before we even graph this, is this a vertical stretch or a vertical shrink? This is a shrink because my factor, which we'll talk about later as the variable a, is between 0 and 1. But what do I have to do to graph this? How am I going to graph this? Make your XY chart. Find your coordinates. -2, -1, 0, 1, and 2. -2, or it'd be the absolute value of -2. 2 times 3/4. 6/4, which reduces 2. 3/2. Okay, we're leave them as improper fractions in case you have to multiply them later. Absolute value of -1 times 3/4. 0 is just going to give me 0. 1 is going to give me 3/4, and 2 is going to give me 3/2. Okay, so my graph of my new function is -2 3/2, -1 3/4, 0, 0, 1 3/4, and 2 3/2. Okay, and what shape is this going to be? It's an absolute value family, so it's going to be good, V shape. Okay, and they also want us to graph the parent function, which in absolute value would be 0, 0, 1, 1, 2, 2, 3, 3, and so on. It didn't shrink much, nope. It shrunk by 25%, right? Because it instead of a whole, it's 3/4, so we lost 25% of the size. Okay. But it definitely shrunk, and again, this confuses people because they say, "Oh, but it got bigger." No, it got less vertical, right? It's less vertical than it used to be, so it was a vertical shrink. Okay. Understand the difference? Okay, so the next thing I want to do is I want to take a look at example 5, and I don't want to, I'm not going to exactly follow their directions. They tell you to use a graphing calculator. If they tell you that on your homework, you can. Okay, but I don't think we need to here, because I think we can look back at our sheets that we have, and I think we can figure it out. Was anybody gone yesterday? Didn't get one of these? Okay. So let's take a look at example 5. It says, use a graphing calculator to graph g of x equals negative absolute value of x plus 5 minus 3 and its parent function. Then describe the transformation. Okay. Well, first of all, I think you should be able to graph that because you would just make an XY chart, right? And you plug in some points. Okay. Second, to graph its parent function, you have to first know what family it belongs to, which, judging by the equation, would be the absolute value family. Okay. And then the second part, it says describe the transformation. I want to just look at this and see if we can come up with it. Okay. So looking at this equation, I have a minus 3 at the end. What would that minus 3 do to my graph if I put it at the end from yesterday? It's going to move it down. Okay. If I were to take this equation right here in red and put minus 3, then this graph would go 1, 2, 3 units down. That's all that would happen if I put minus 3 at the end. Okay. So that minus 3 at the end of our equation there moved that graph down 3 units, right? Okay. That plus 5 on the inside, what did it do? You can look at your sheet if you need to.
It's greater than 1. Which it?
No. No, I'm not looking at. You see what I'm looking at? I'm not looking at a multiplier. I just took x plus 5. It's still a translation. It's a horizontal translation. Which direction did it go if it says plus 5? That's the tricky one. It went left. Okay, look on your sheet where it says horizontal translation. Notice that it says x minus h, right? So the only way to make that a x plus 5 is if h was negative 5, right? So I actually went left 5. I could do that to this graph if I wanted to. If I did that to this graph, it would take this and it would go 1, 2, 3, 4, 5, and it'd be right there. Just by putting a plus 5 in here.
Will it ever go right?
Yep. If it went right, it would be minus 5. And it'd be over here. If it was there and minus 3 like it is in our book, it'd be down here.
Interesting.
Why is it flipped in the book? I don't know what you mean by
It's
that.
upside down.
Oh, well, yeah, we're not done yet. That's that negative sign out in front. Okay? That reflected it in the x-axis. Okay? No, it's not. You got it. You got it. Okay? I want to do one last example. This one's similar to the example 6 that you have in your textbook, but it is a different one. Okay, so the problem that I'm going to give you says the table shows how many miles you are from home after X hours. What type of function can you use to model the data? And then estimate the distance after 4.5 hours. So what I have here for a chart, I have time in hours, and I have distance in miles, and I have 1, 2, 3, 4, 5, 6 hours, and I have 50, 90, 130, 90, 50, 10. Now the problem is my graph does not have that big of numbers on it, right? What can I do? Yeah, don't go by 1, go up by 10 probably in this case, right? So I actually have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Is it okay to change the scale of my y-axis but not change my x-axis. Yeah. Okay? As long as you label it, it doesn't matter. I could change it to whatever I want. Okay? Because if I changed my x to 10, this would be really hard to draw, right? Okay. So now I go ahead and graph these. 1 hour after I've left home, I'm 50 miles away. 2 hours, I'm 90. 3 hours, I'm 110, 20, 30. I'm just going to do my best there. 4 hours, I'm 90. And 5 hours, I am 50. And 6 hours, I'm 10. Okay. What type of function is this? What function family does this appear to be? It appears to be absolute value. Those of you who are trying to decide between absolute value and quadratic, a quadratic wouldn't end up in such straight lines, right? A quadratic's going to curve, okay? So it won't end up in such straight lines like this did. So that's an absolute value function. Okay, and let's see, what else? Did I miss anything? What type of function can you use to model data? Absolute value, we just said that. Okay, the last part of the question says, estimate the distance after 4.5 hours. Okay, well, if I knew the actual equation, all I'd have to do is plug in 4.5, correct? Check Big Ideas, it's online. Okay. If there's an equation, I could just plug in 4.5. Okay. Since there's not an equation, but I already have the graph, what can I do? Okay, I don't actually have to make an equation. Where's 4.5 hours at? X or Y axis? X, I could go to 4.5 hours, go up. Where am I at after 4.5 hours? 70 miles. So the answer is, after 4.5 hours, I am 70 miles from home. That's why we had to graph that. Because once we have it graphed, you can give me any time I want, and I can just go right to that number, 5 hours, or 3.5 hours. Looks like we're going to be up here in the one, it's hard to tell because it's off my graph, the 120. After an hour and a half, I'm going to be at 70. After an hour and 45 minutes, I'm probably up here at 80. Okay? Does that make sense, how we read that graph? Okay. The only other question I have for you before we work on our assignment, when you do real life problems, typically your graph is not going to go on the left side of the y-axis. Why? Yeah, a lot of times you can't have negatives. For example, right now, I cannot have negative time, right? Okay, I could not have been asked you, well, after -1 hours, how far would you be from home? That doesn't even make any sense. Okay? There are certain scenarios where your x can be negative. Can you give me one? When could your x possibly be negative? Yeah, in a real life problem. Olivia? Money. You can have negative money, right? You could be in debt. Hey, that'd be an issue. I would hope you never are. Okay? Without a loan, anyways. Hopefully you're just not in debt to somebody else. Have no money and borrowing money from people. That wouldn't be good. Okay? There's one other that I can think of off the top of my head. Has to do with the weather. Temperature, right? Could be negative temperature. Okay? Those are the two most common that I would say in a word problem your graph can go negative. So what's going to happen is we are going to have graphs that are like parabolas, but they're going to go like this. And actually, they're going to stop here. Okay, well, it's still a parabola, right?
Yes.
We just can't be negative, so the graph stops. Okay, it will not be uncommon for a word problem or a real-life scenario problem to have a graph that looks like that. Okay, so don't think that's weird when you see that. Okay, just the fact that I think the actual example they use is a dirt bike, and I don't know what they're talking about, but I think it's maybe height of a jump. Well, the jump can't be negative, right? If you're jumping up in the air, you're not going to go under the ground.
They're saying how long he stays up in the air.
So then the other one's time.
Yes.
Time can't be negative. Okay? So just be aware of those things. Okay? Any questions? Okay, work on the rest of that assignment then.